Namaste. This is exclusively for PUC students. Physics topic, first year physics topic for competitive examinations. Today we will start with first part of the synopsis. That is, our topic is first year topic, motion in a plane, work, energy and power. Today we will cover only motion in a plane. Under motion in a plane, what we have first is projectile motion. Importantly, projectile motion. So a graph you can see here. This is a graph of projectile motion of a particle. Some terms you can see here. We will see what are those. Before that, what is this projectile motion? You know what is motion. So what is this projectile? That is a body thrown into space making an angle with the horizontal under the action of gravity. You know what is that? A body thrown into space making an angle with the horizontal. Horizontal direction is this. This is the vertical direction. So what is the angle? Angle made by the projectile is theta naught. That is with the horizontal. Okay. This angle. Okay. This angle. Right. Under the action of gravity, that is projectile. Path of projectile is parabolic. This path or trajectory. Another word for path is trajectory. You know, that is what? Parabolic. The shape is parabola. Parabolic in shape. So the trajectory or the path of the projectile is parabolic. So what are the terms? V naught. This you can see. Initial velocity, theta naught, angle of projection, V naught cos theta naught, horizontal component of V naught sin theta naught, vertical component of V naught. As you know, V naught is vector, it has direction. So this can be splitted into two components as vertical component and horizontal component. This is horizontal, this is vertical. So two components you can get. What is V? V is velocity of it at time t. At any time t we can see V as the velocity of the projectile. It is not V naught. It will change. So HM you can see in the figure. HM, maximum height reached by the projectile. That is maximum height. First important equation here you have is for HM, maximum height, V naught square sin square theta naught by 2g. You can see what are the terms. Here it is already explained. So what is g? G is 9.8 meter per second square acceleration due to gravity. Right. Coming to the next point, that is R, range. Range is horizontal displacement. You can see here. This is the range. This is the range. The maximum displacement it had along horizontal direction. What is the equation for R? R equal to V naught square sin 2 theta naught by G. You know the terms. I will not explain it again. So maximum range or maximum for a particular value of V naught, what will be the maximum range? So how you can get maximum range? When you will get maximum range, that depends upon theta naught. When V naught is maintained constant or it is not varying, theta naught will be the varying factor. When it R becomes maximum, R maximum means when theta naught is 45 degree, R maximum equal to V naught square by G. So why it is so? You can see here sin 90 it becomes 45 into 2, that is 90. Sin 90 is 1. So it is the equation important, underlined, important. Okay. Next, time duration. The time duration during which the projectile was in flight. That is, was flying. The time duration during which the projectile was flying. That is what you call as time of flight. TF. You may be knowing all these things because it is already covered in your theory part. So, I know you are very brilliant. So, you can remember once again here. Due to lockdown, you may have forgotten it. So once again remembering is my duty. Tf equal to 2 V naught sine theta naught by g. Third equation we have now. Third equation, important, again important. Remember, note down these things. G, gravity, that or acceleration due to gravity, already explained. No need to explain it. Very simple. As you are very brilliant, you are very familiar to these things. Now next, time of maximum height. You know what is maximum height? In this you can see this is maximum height. So time of maximum height is the time taken by the particle to reach maximum height. That is given by Tm equal to V naught sine theta naught by g. When theta naught is 45, when this becomes 45, what is the value of Tm? V naught root 2 by g. Okay, you can substitute the value of sine 45 there, you will get this. Next up, that is this Tm equal to V naught root 2 by g is at R maximum. So when this value is given, you can obviously say R is maximum. You know what is the value of this also. I have explained it, right? So don't worry. So remember this. Directly question may be asked about these equations. Regarding these equations, putting these two equations together, or for Tm and R maximum, several questions can be formed. We will see what are those in the part that we are going to discuss in later videos. For a given V naught, for particular value of V naught, just imagine you are throwing it 2 times to the space. It is projected 2 times. My condition is V naught is same. Both the times V naught is same. R is also same. But this angle, you know, these angles, that is angle of projection, theta naught is same. Theta naught is not same, of course. It is different. 2 times it is different. So what is the condition? If it is so, V naught is same value, R is same, then theta naught and 90 minus theta naught are the angles of projections if they are different. Remember this. For theta naught and 90 minus theta naught, R is same for given value of V naught. If for theta naught, Tf is T1f, for angle of projection, that is 90 minus theta naught, Tf is 2, that is T2f, then the condition is T1f into T2f is equal to 2R by G. Remember this. Once it was directly asked, this is important, once it was directly asked as question, giving 4 options. Okay, in planar motion in a plane, what we have next is a circular motion. Circular motion. See, here we imagine a particle is moving in a circular path, its mass is m, and we consider t is the time in which angular displacement is theta. This is angular displacement. Angular displacement, you know, here to here, that is theta. Okay, here the velocity is v, here at this point velocity is v dash. By tangents, we have shown the direction of velocities at these 2 points. Okay, R is the radius of circular path, and here this is the AC. Okay, we'll see what is that. Here I can say AC is centripetal acceleration. Okay, next, what and all we have to remember here. Velocity of the particle changes from point to point. You can see at this point velocity is v, at this point velocity is v dash. So velocity changes, speed may be uniform. In a circular motion, speed may be constant or uniform. What is speed? Magnitude of velocity, right? So it may be same, but direction changes. That is why velocity changes, as it is a vector. The tangent at a point shows the direction of velocity. As already I have told, time taken by the particle to complete one revolution is known as time period. For completing one oscillation means starting from here, completing one revolution, oscillation. Here it is revolution. Revolution. Time taken. Total time taken is time period. It's a time period. Important. T. You know that. Number of revolutions per second is frequency. It may be F or nu. If it is F equal to 1 by T. This is the relation between these two, time period and frequency. Time period and frequency, two things. Okay. Angular velocity. One more term, omega equal to angular displacement by time. Angular displacement is a theta. This one, theta. You know, theta. Okay. By time taken to have that displacement. Therefore, one more thing you have to remember here, in one complete revolution, this omega, that is angular velocity, is given by 2 pi by T, because around this point, what is the total angle? 360, means in radians 2 pi. So angular displacement is 2 pi. So this is 2 pi by T. 2 pi into 1 by T, right? That one is 2 pi F, because 1 by T is F. Okay, relate. You can revise this. Okay, next I'll move. That is linear velocity V equal to R omega. Okay, this V, R into omega. R is this, omega is this one. This one. Okay, theta by T. I explained already. So in one revolution, V equal to 2 pi R by T, that is 2 pi RF, as it is here. 2 pi r is circumference of the circle, that is the distance or displacement now. So linear velocity will be total displacement 2 pi r by T, time taken or time period for, that is for one revolution. Okay. Centripetal acceleration. Now this one, centripetal acceleration. What is that? Definition wise, definition will not be asked for competitive examination, but you have to remember for that reason. Centripetal acceleration is the acceleration directed towards the center of circular path. It's the direction. Acceleration is a vector quantity, should be having a direction which is directed towards the center of the circular path, AC. Okay. This is given by V square by R. V square, you know, what is that? What is that? That is a linear velocity. R is radius. So omega square into R, that is equal to V omega. So three equations you have. AC equal to V square by R and AC equal to omega square R, or AC equal to V into omega. Okay, moving to the next, centripetal acceleration into mass. Acceleration into mass, A into M, that is force, right? So centripetal force, that is also directed towards the center, is equal to FC equal to AC into M. AC, what is AC? Centripetal acceleration. M is mass of the particle. So three equations you can get here. M into V square by R, M into omega square R, M into V omega. What and all you have in the inside the brackets, all those are ACs. AC, equations for AC. You can refer back if you want. Direction of centripetal acceleration is normal to that of velocity or displacement. Okay, direction of centripetal acceleration, this one. Again, I'll go there. I'll show that. Velocity or displacement. Velocity is here. Acceleration is here. Angle between them is 90 degree. They are perpendicular to each other. Okay. Work done in circular motion, omega, W. Not omega, W. Work done is Fs cos theta, you know. F is force. S is displacement. So here this F is centripetal force. Displacement. You know what is the angle between them? 90 degrees. So this work done is 0. So you remember wherever it is asked, work done in circular motion is 0. Okay. In uniform circular motion, you have to